All right, what up, everybody? This is Mr. Stan coming at you with another physics video. And this time we're talking about convex mirrors, right? So, a convex mirror looks like this. You can see the mirror kind of bulges out in the middle and is more skinny at the top and bottom. And here we have Sir Roach, who's going to demonstrate um, how the light rays bend and show an image and what image you would see from the convex mirror. So, first of all, I'll show you three special rays that do the same thing each time, and you can draw them. The first ray is one that starts parallel to the ground or parallel to the axis, as we call this, and it's going to reflect directly away from the focal point on the right side. Okay, so just imagine a line that goes from where it hit the mirror to the focal length on the other side. And of course, that would be an imaginary line because the light ray is not allowed to pass through the mirror. But if you continued this imaginary line over here on the left side, you would get the actual real ray. Okay, so that's where the light would reflect. The second type of useful ray to draw here is one that goes to the center of the mirror. Okay. And when it goes to the center of the mirror should be vertical at that point, and so it just bounces off in the same angle. So you can just, whatever angle it makes with the axis right here is the same angle you'll have on the other side. And then we'll also continue this reflected light ray back behind the mirror to give you a virtual light ray back there, which might be important depending on where the image is. And the third ray is one that is headed towards the focal point on the right side. Okay, so you can imagine if the mirror didn't block this ray of light would head directly towards the focal point on this side. But when it's reflected, it's going to go back on the left side and it's going to be parallel to the ground. Right. And so we'll continue this reflected ray out behind the mirror to give us a virtual ray, which might be useful. And those are our three rays. So just summarize those. The first one starts parallel, bounces away from the focal point on the other side of the mirror. Second one lands on the very center of the mirror, the part that is vertical, and it bounces off in the same direction that it came in. All right. So and then it okay. So the third ray will leave and head towards the focal point on the other side of the mirror, but it'll never make it because the mirror is there and it bounces off parallel. Okay, so to find his image, we're going to have to use two rays and find where those lines cross. So I'll start with ray number one, parallel at first, and it's going to bounce off away from the focal point on the right side. Okay, so I'll draw an imaginary line from where it hits the mirror to the focal point on the other side, and just continue that line, see where the light ray would reflect. The second ray I'm going to use is the one that goes to the center of the mirror, right? And it's going to reflect with the same angle that it came in. And I will continue that one out. And so you see where the two lines cross is going to be on the virtual side. And so you get a small little virtual image over here. That image is upright, it's smaller, and it is virtual because there are no real light rays that go from the top of that go from here to where Sir Roach is standing. Okay, but let's move Sir Roach much closer to the mirror. So now he is inside the focal length, right? And we'll see that something. Let's see what happens here. Okay, so I'll use ray number one. It's parallel at first, but it's going to reflect away from the focal point on the other side. I'll draw that imaginary line that goes from where the light ray touches the mirror to the focal point. Continue that on the other side. Next, I'm going to use the second ray, and it's going to reflect off the middle like that, and then it's going to we're going to continue the reflected ray off to this right side, right, which will give us the crisscross that we need to see where the image will be. So the image will be right there. And you can see that it is still upright. It is still smaller than the object, right? His Sir Cockroach is looking at himself in this mirror, and he still looks smaller. And it's still virtual. A difference is he did get the image is larger than before. So it appears that with convex mirrors, the closer you get to the mirror, the larger the image will be. But it never gets to be as large as the actual object. Right. Okay, so that's convex mirrors, and I'll see you all in the next video.